Hello everyone, welcome to Pre-Algebra with Miss Betsy. I'm glad that you are here to join us today. What we're going to be discussing and illustrating today is how to solve an equation when it contains a rational expression. If you happen to be tracking along with me, the text that I'm using is published by Bob Jones University Press. It is entitled Pre-Algebra for Christian Schools. I'm using the first edition. You don't have to use this text, of course. You can still get a good review or a good introduction, whatever the case may be, to how to solve equations that contain fractions just by watching this. If, however, you are with me, we are on page 200, section 6.7, and it's entitled Solving Equations Using Addition and Subtraction. Before we begin, my lame joke for today, what dinosaur is at home on the range? Well, it is Tyrannosaurus rex. Home on the range, where the dinosaurs and the antelope play. So let's just go ahead and dive right into our lecture. Just with a brief review, what exactly is a rational number? Where a rational number is something that takes the form a over b. A and b are integers, and b is different from 0. b is not equal to 0. And why can b not be equal to 0? Because you cannot divide any number by 0. So a rational number is what you have up to this point known as a fraction. And we have been reviewing how if you wish to add or subtract fractions that you need to have a common denominator. Common denominator would be the first time that you have a multiple of two numbers that agrees with one another, where you have the same multiple in both sets of multiples of the number. Sorry, my tongue is tied a bit there. Multiples of 6. 6 times 1 is 6. Times 2 is 12. Times 3 is 18. Times 4 is 24. The first multiples of 4, 4, 8, 12. Well, right there, 12 is the first time, is our lowest common multiple, or our least common multiple. They call it the LCM. What we're going to do is rename 1/6 and 3/4 with a fraction as fractions with denominators of 12. So that if we had 1/6 plus 3/4, we would rename that to 2/12 plus 9/12, and then we would be able to see that our sum of 1/6 and 3/4 is actually 11/12. And the way that you can come up with your common denominator, other than writing out a list of multiples or looking at it and saying, oh, well, I know with a 6 and a 4, the first number that they're going to have in common is going to be a 12. You can use prime factorization to find both your greatest common factor and your least common multiple. And you can search my videos, and there's already a teaching out there that will review that for you if there's something that you need to do. So let's dive right into our first example. And we're just building on what you already know about how to solve basic algebraic expressions, basic algebraic equations. X plus 3 is equal to 17. You know just by looking at that x is going to have a value of 14. But what's the methodology? What process lets you do that? Well, the concept of inverse operations, undoing one another. We began with an x. We added 3 to it. Now if we undo it, we use our inverse operation, and we're going to subtract a 3. And we're going to be right back where we started. On this left-hand side of the equation, we just have an x. First you add 3, then you subtract 3, and we're right back where we began. We learned also that when you're dealing with equations, as long as you perform an operation on one side of the equation, you do exactly the same thing on the opposite side of the equation. Might not look the same, but it has the same value, then that equation remains in balance. So since we've subtracted 3 from this side of the equation, we had to subtract the 3 on the right-hand side of the equation as well, giving us a value of 14, which you knew a long time ago that x here has the value of 14. And that's all we're going to be doing today, is that instead of using integers, we are going to be dealing with rational numbers, or with fractions. So let's say that we have x minus 2/5 is equal to 9/10. And this is actually example number 1. And I believe this is found on page 200. It's on page 200 in your book. So what are we going to do? What action has been performed on this variable x? Well, it's had 2/5 subtracted from it. Well, what's the inverse operation for subtraction? It's addition. So we have x minus 2/5. So we're going to add 2/5 plus 2/5 is equal to 9/10. Now our equation had been balanced, but we added 2/5 to this left-hand side of the equation here, so it's out of balance. What do you have to do to maintain balance in our equation here? You have to add 2/5 to the right-hand side of the equation as well. Now our equation's back in balance. All we've done is we've added 2/5. We have x is equal to 9/10 plus 2/5. Can you add those two fractions together? No, you can't, because the denominators are not the same. You have to have a common denominator to add fractions, which means that you need to rename these fractions with a common denominator. Common denominator here is going to be 10. X is equal to 9/10 plus 4/10. X is equal to 13/10. I am happy. This is where I diverge from, I'm speaking specifically to my students. This is where I diverge from your book. I do not require you to change that into a mixed number. As long as you have your improper fraction reduced to lowest terms and your problem instructions don't specifically tell you to rename that fraction as a mixed number, you don't have to. However, I'm not going to count it wrong, of course, if you change this into a mixed number. Or x is equal to 1 and 3/10. Do you have to have both of those answers there? No. But I'm satisfied with either of these two answers because this is an improper fraction in lowest terms. This is reduced to the form of a mixed number, or has been converted into the form of a mixed number. See, there's really no difference at all in what you've already been doing and what section 6.7 is teaching you. So let's go ahead and do another example. This is example number 2. 1/4 plus y is equal to 5/6. 1/4 plus y is equal to 5/6. Now what is our goal when we're solving equations? What we want to do is we want to isolate the variable. I don't care what y and 1/4 is, I don't care what 5y is, I don't care what minus 2y is equal to. I want to know what one single y is all by itself. So what we do is we isolate the variable. We get the y or the x or whatever that variable is all by itself on one side of the equation. We do that by performing inverse operations. We have a y here. We've had a 1/4 added to that equation, to that y, so we have 1/4 plus y minus 1/4. I'm going to subtract 1/4 from both sides of that equation. make sure that you perform the same operation on both sides of the equation. 1/4 minus 1/4 goes away. You have y is equal to 5/6 minus 1/4. Here you have to be comfortable enough with your fractions to rename these, to know that you have a common denominator of 12. So y is going to be equal to 10/12 minus 3/12. 1/4 is the same as 3/12. 5/6 is the same as 10/12. The denominators are the same, so we subtract the numerators, and we end up with 9/12. Is that a correct answer? Yes, but you're still going to get it wrong because this fraction, this rational number here, has not been reduced to lowest terms. It has a common factor of 3. A couple of different ways that you can think of this. You can just say y is equal to 9 divided by 3 over 12 divided by 3, which is 3/4. That's one thought process that you could use. I'm sorry, I'm going to sneeze. Or you can factor 9 and 12, and you can cancel common factors. You could say that y is equal to 3 times 3. 9 is equal to 3 times 3. 12 is equal to 3 times 4. There's a factor of 3 in common that you can reduce. And y is equal to 3/4. Whatever methodology you use, you have to make sure that your final answer is a rational number. It's a fraction in lowest terms. It may be a proper fraction, where the numerator is smaller than the denominator, or it might be an improper fraction, like the last one was 13/10, but it has to be reduced to lowest terms. Now, how are we going to know if this answer is correct? Ten minus 3 is 9. It's not. This is a really good illustration right here. See, you think that I'm just going along doing your problem, answer's 3/4, and that it's really a waste of your time to check your problems. If you go ahead and look at page 201, you have the solution, and then you have where it says to check. Now, how did I know that this was wrong? Some of you caught this error that I left in here, but I didn't say anything about it, did I? What's wrong with that? 10 minus 3 is 7. 10 minus 3 is not 9, but we kept right on going as if 9/12 were the answer. So I had 9/12, which reduced to 3/4, and then I said, okay, let's go ahead and check this. How do we know, how can we verify that 3/4 is the right answer if we didn't immediately catch that I wrote 9/12 instead of 7/12? What you do is you take your value for y, substitute it back into the original equation. And that's where it jumps out at you right away that you've made a mistake. Because 1/4 plus 3/4 is definitely not equal to 5/6, is it? So this procedure right here, where you take the value that you arrived at for your variable, that's how you go back and check it. You take the time to check your solutions, and your error rate will go way down. Because you'll just be moving along, cranking stuff out, and maybe you'll get distracted by a text. Maybe you're listening to your iPod, maybe your dog comes in and you play with her for a bit. But you get careless, or you miss something, or you're trying to write a 7, and instead of a 7 you write a 9. take the time at the end to do your check, and your check's going to show you, oops, I did something wrong. Let me go back and see what it was. And in our case, you would discover that 10/12 minus 3/12 does not equal 9/12, it equals 7/12. So, let's go ahead and do our check now. Check. And make sure that y equal to 7/12 works. Okay? 1/4 plus 7/12, is that equal to 5/6? Well, we have three different fractions here, three different denominators. Let's go ahead and rewrite everything with the common denominator. 3/12 plus 7/12, is that equal to 10/12? Yes, of course, when you add your numerators together, you see that now you do have the correct solution of y is equal to 7/12 for this equation. That's all that's involved in solving equations that contain rational numbers. Enjoy those. I'll see you next time.